Hello, Les Tilson here. In this short video I'd like to show you how I design the templates to make the horizontal laminates that I use when I build a curved string. Horizontal laminates is a technique that I put together quite a few years ago to build curved parts like curved strings on curved stairs. At the time, before I made this technique, I used to make curved strings in solid wood or eventually in traditional laminates that are glued up onto a form, a curved form. I found that these two techniques had their disadvantages, and one of the main disadvantages being that they're very time consuming. And so I designed another technique which I called horizontal laminates, where you don't need a form but you have the advantages of the laminated technique. This technique of horizontal laminates can be used to make practically any curved part, and the only real restriction is that the part has to be relatively thick. It has to be, I would say, at least 50 or 60 millimeters thick for the laminates to have enough rigidity to maintain the form. If you want more details about the actual the technique itself, go over to my website. There's plenty of little articles and some videos on how what the technique is and how to use it. In this little video I'm just going to show how you actually get the real shapes of the laminates and how you design the template that actually gives the shapes. Right, to design these templates, what I usually do when I'm building a stair is I build the design in StairDesigner, my stair design program. Here I have a stair which I've just quickly thrown together as an example in StairDesigner, and I take the design and I'll take the file export option, export the stair, and I'll export the stair in a 2D DXF plan. This file I will then load into a CAD program which I use called ProgeCAD, which is exactly the same thing as AutoCAD if you have AutoCAD, but you can use any CAD program like AutoCAD or SolidWorks or TurboCAD, whatever program you use. You can even use a free 2D program like DraftSite, which works perfectly well for this particular operation. I'll show you how to do that now. Okay, now here we are in ProgeCAD. I've loaded the 2D DXF drawing from StairDesigner into ProgeCAD, and we can see here that we have the whole stair in 2D. We have the plan and the elevation of different strings. What I'm going to do now is I'm going to separate the different parts of the drawing that I'm going to be working on from the global drawing, so that we can be easier to just work on separate parts. The parts that I want to separate, in fact, are of course the plan of the curved string and the elevation of the curved string, and these two parts I'm going to copy them and paste them into another new clean drawing, which is in fact a template drawing with different layers set up and different text styles set up, so that I don't have to do this every time. So the first thing I'm going to do is I'm going to use the edit and copy command, and I'm going to copy this elevation of the curved string. And note that I copy the whole string with the steps, and I also copy what we call the springing lines, which are these two vertical lines here, which are the joint lines or the lines where the curves start and finish. What I want to copy as well is I want to copy the plan view of the actual string itself, to have the curve of the plan, the curve of the string in plan. So I select those and I just say OK for that copy, and I go into my template drawing here, which is an empty drawing, and I've just set up a few layers and a few text styles so that it's going to be all ready. And I'm going to just choose the edit and paste command. I paste it to the original coordinates. So we have the two things from the other drawing, the plan and the elevation from the other drawing. Now let's just set it up a bit and make it a bit easier to actually work on. let's just move a bit the parts around. For instance, we can move the parts around so they're closer together here. Okay, now they're much closer together and they'll be easier for me to work on. The first operation which I'm going to do is I'm going to draw on this the elevation. Now the elevation is in fact a development, that is, the strings, the straight sections are as they are, and this curve section is a stretch out of the inside of the string along this curve here. What I'm going to do is, the first thing I'm going to do is draw in the joint lines, the real joint lines that I'm going to use to join the curved part to the straight part. To do that, I'm just going to draw in a line. Let's zoom in a bit here. I'm just going to draw in a line, for instance, around here, and I'm going to give it a slant. I use myself what I call crochet joints. I can show you some photos of the crochet joints from my website. Crochet joints allow me to bolt the string together in a very tight and a very strong manner. These crochet joints, I'm going to draw them in place onto the string, and note that I put them at the same slant if possible, and what I do is I put them on the straight section of the string if possible. They don't go into the curve. This makes it much easier to assemble. The crochet joints, I'm going to draw the crochet joints in. These crochet joints are in fact 20mm joints. I will show you. I'm just going to draw them in quickly, and you'll see how they are designed. I'm just going to trim the two parallel joint lines to the string, and when I get into the string here, I'm going to draw what I call the crochet, which is in the middle of the string, and the joint actually has this shape. Here we have the crochet joint. It's a broken line with a little break here, and the bolts that pull the joint together will pull that joint very tightly and very neatly together. I'm going to put in the crochet joint on this lower end of the string, and here we have the two joints. The positioning of the joints. These joints can be practically anywhere on the string. It's of no real importance. What I'm going to do now is I'm going to draw in the actual horizontal laminates. The horizontal laminates, I'm going to take a horizontal line, and I'm going to put a horizontal line here at the bottom of the string section. This is the curved section of the string now. This horizontal laminate, I'm going to give it a certain thickness, and I'm going to copy this line up through all the curved section here. I'm going to use the array command, and I'm going to say that the number of columns is only one column, but I'm going to give it, say, about 30 rows, which is going to draw in the actual thickness of my horizontal laminates. Sorry. In the row distance here, what I'm going to put in, which is the distance between each element, I'm going to put in the thickness of the horizontal laminate. Now, horizontal laminates I use usually between 30 or 50mm. So let's say I'm going to use 40mm this time. I'm going to select the element that we're going to array. It's going to be this one here, and I'm going to say OK. And you can see that the ProgeCAD here has just drawn in my parallel lines. I've got a few too many here, but this is not really important. I'm going to just erase these ones. Let's just erase the top few, so that the whole curve section is actually engulfed in my my horizontal lines. It's horizontal, which represent the horizontal laminates. Now let's just trim these horizontal laminates to the string itself. So let's trim it here, and let's trim the horizontal laminates to the joint lines. Just trim into the joint lines. We don't need this one now, which was the first one which we had. Trim this to the joint line. Right, that's fine. Rid of this one. Now, this is the actual development of the curved section with the horizontal laminates drawn in. We can see that if these horizontal laminates, if we put them on the plan, each horizontal laminate here is different. We don't want to have to machine up each part differently. So what I usually do for this type of string, the easiest thing to do is to define blocks of laminates which all have the same shape. Let's say that we're going to use blocks of laminates, 6 blocks of 6 laminates will be cut from one single shaped block. The way I do this, I'm going to design the blocks, and I'm going to add a horizontal line here. This horizontal line, we're going to divide the total number of laminates into blocks of 6. So I'm going to use my array command again, and the number of rows, let's say I want to say 5 or 6 rows, I don't know exactly how many, but the distance between the rows will be 6 times the thickness, which would be 240 millimeters. And if I go OK, here we have now 1, 2, 3, 4, 5, and we have 6 lines. In fact, 1, 2, 3, 4, 5, 6 lines. We don't really need this top line here because it's outside the zone of the curved section. This particular line here doesn't quite go to the top of my curved section, so I'm going to move it to the top of the curved section here. So we have one section here which is a bit more than 6 laminates. Now, each section here represents 6 laminates, and I'm going to design the limit, give the limits of the block which we can use to cut these laminates. The first thing I'm going to do is here, for the first block, will be from here to here. So this will be the first block. See, this rectangle I'm drawing, this rectangle I have drawn here in yellow contains the first 6 laminates. So all these laminates, I'm going to use the position of this block to machine all these laminates the same. The second block will be this shape. This block here contains all the next 6 laminates. We can see that the beginning here, the start of this block and the start of this block are pretty similar. So to make it much easier, let's just put these along exactly the same line. So that the blocks here, the starting point of these 2 blocks will be exactly the same. The blocks, the next series of blocks, or the next block, will go from here to here. And this is the next block. Sorry, let's put that over there. This next block here will contain these 6 laminates, and the last block will be from here to here, and from here to here. The last block will contain these 6 laminates. Well, there's a bit more than 6 here, it's probably 7 or 8 laminates. As we can see, as in the last case, the back of this block here is nearly aligned with the end of the section of the curved part. We're going to line it up with the section of the curved part to make it easier to mark out. So we have now here 1, 2, 3, 4 blocks, and each block contains 6 laminates. Let's put some text into this. Let's just number the blocks. So we have, let's say we have block number 1 here. Let's move this over. Here we have block number 1. Let's number the other 2 blocks. And this is block number 2. And this is block number 3. And this is the last block, number 4. So we're now going to draw the plan view of each block, and this will give us, the plan view will give us the actual shape of the block that contains the different laminates. First thing we do is we're going to position the start and the end of each block relative to the springing lines. We do this with we're going to just put a few dimensions on it. For instance, here the beginning of the first and the second block is at 198 millimeters from the first springing line. The third block is at 54. The fourth is 122. The back of the first block from the springing line is 143, and the back of the second block from the second springing line, it's very nearly on it, in fact is 6 millimeters. And the back of the third and the fourth block from the springing line here to here is in fact 210 millimeters. Okay, we're going to use these dimensions now to draw the plan view. First of all, on the plan, the front edge of the first and the second block is at 198 millimeters from the plan. Let's draw in a line here which represents the springing line, or overflow of the springing line, and let's just move it downwards 198 millimeters, this distance here. Now we know that this is this vertical, which represents the front edge of the first and the second block. The first block will go behind the springing line 143 millimeters behind. To do that, we take a circle, click it onto the springing line, type in 143, and then take in a line from this intersection and perpendicular to the other side of the circle. This now represents the back edge of the first block. Right, working on the first block, let's trim the first string to the first block, to the first edge of the first block, and let's trim the first block, this line here, to the edge of the string. Here we have now the first block starts here and finishes here, which is quite good. Let's copy the number 1 and put it on here and here. We know this the shape now, the approximate shape of the first block is from here to here. We now know that the second block, the front of the second block is aligned with the first block, and the behind the second block is 6 millimeters behind the second springing line. So let's draw in the second springing line. Let's extend the second springing line with a construction line, and let's move this construction line 6 millimeters behind. Now let's trim this construction line to the width of the string, and let's put the number 2. The number 2 will now be, the front of the 2 is here, and the back of the 2 the end of the 2 is here. We know that number 2, layer number 2, goes from this line to this line. Right, let's do the same for the number 3. Number 3 is at 54 millimeters in front of the front springing line. So we can take a horizontal line and we can move it 54 millimeters in front, trimming it to the width of the string. And the back edge of the block is 210 millimeters from the back, the second springing line. We will do the same here. Second springing line. Let's move this line now along the string at 210 millimeters. 210 millimeters. And again, trim this line to the string. We know also that this 210 millimeters is also the back end of the third and the fourth block. The fourth, the beginning of the first block, is at 120 millimeters from the front edge. From the front edge of the is at 122 millimeters from the first springing line. Sorry. So 122 millimeters circle, and the front edge will be from here to here. And so with the fourth, the front edge of the fourth block will be here, and the back edge of the fourth block will be here. And this back edge of the fourth block, I haven't put in number 3. Let's put in the number 3. Oh, I forgot to put in number 3 is here, and it's also here. Of course, this is the end. Also, the last is the end of the actual curved section of the string. So let's trim to this line the string. And here we have the nearly finished the template that we can use to machine up the horizontal laminates. One thing that's missing is the actual outside thickness of the string. Here is the final thickness. We don't want the final thickness. What we want is the final thickness minus the thickness of the veneers that we're going to glue on the outer faces. To do this, let's go on to another layer and let's just draw in a polyline that enable us to quickly set up. Here we have a polyline, and we're going to offset this polyline the thickness of the veneer 2 millimeters here. We're going to offset it now 56 millimeters to have the other side of the actual core, so that'll be another 2 millimeters from the other side. And let's do an offset of 30 as well, so that we can get the center line. Let's get rid of the first polyline, we don't need any more. And now we have the actual shape of the template is in fact what is brown here. Let's get rid of the actual, well, let's just overwrite these lines here, the springing lines, and let's now hide the actual string. Right, here is the actual template that we can print out. We're missing now, the one thing we're missing is the actual the holes that we need to push the dowels through, that will keep all the horizontal laminates lined up for the gluing, and will reinforce all the joints. To do that, we just take a draw point and a division, and we say on this one, let's put, for instance, 14 divisions, and the program will actually draw in the different centers of the holes that we need to drill. And that is the actual shape that can be printed out full size and be used to make the template to build the horizontal laminates. If we have a look in 3D, I'm a little 3D model here. and this shows us the first block of laminates, the shape of the plan view of the first block of laminates. I can look into the second block of laminates is here now. Let's have a look. That's the second block, and the third block will be here. Shape of the third block, and the shape of the fourth block will be something like this. As you can see, they all go around the plan, so that if we see we load up the 1, the 2 and the 3, they all fit onto the plan view. If we show the blocks, we can show the blocks all built up, 1, 2, 3 and 4, and let's zoom out a bit and let's give a shade. And here we are. Here we have the blocks as they would appear once glued up, ready for machining. So that, and the edge, cutting the edges and putting on the face laminates. Okay, so I hope that's been a little bit of interest to you, and if you have any questions, don't hesitate to call me or send me an email, and go over to my blog and have a look how I build stairs using this method. Thank you very much indeed. Goodbye. Be seeing you soon.